Hi, welcome back to Intermediate Algebra. Today we're going to start quadratics. So in particular, we're looking at section 7.1. We're going to do what's called completing the square. So we have a couple of things to look at before we jump into actually completing the square. But it's a fairly straightforward process, but I'll be honest, a lot of people don't like it. So just kind of hang in there, pay attention, and take some notes, watch the video a few times, and hopefully we can get this to work for you. So, completing the square, that's what we're aiming for. So we're going to work in this section based off of this idea. If a squared is equal to b, okay, so think x squared equal to a number, then a is either the positive square root of b or a is the negative square root of b. We can also write that as a is equal to plus or minus the square root of b. That gives us both answers at the same time. So it's really important to know when we solve by taking a square root, there are always going to be two solutions, one positive and one negative. And so we have to always remember that. It's a really easy thing to forget about. That negative part of it, that's usually the one that gets left out. But you don't want to forget it. So anyway, that's what we're going to be working with here. We're going to be working with solving by taking square roots. All right, so here's my first example. And it's a little bit more complicated than x squared is equal to a number, but not too much. I have, in parentheses, 3x minus 1, and then that's all squared equal to 36. So it kind of fits or very much fits what we have over here. So we're going to start by taking the square root of both sides. And you'll notice on the left, the square root gets rid of the square, which is what we really would expect to happen. On the right, it's super important we keep that plus or minus. There are two solutions here, one positive, one negative. In this case, positive and negative 6. But now I have a little bit of a dilemma. I don't actually have x by itself yet. Right? I have 3x minus 1 is equal to plus or minus 6. As tempting as it might be, you can't just start adding and then dividing to solve this. We really need to split it into two parts first. We need to split it into 3x minus 1 is equal to positive 6, and 3x minus 1 is equal to negative 6. So that way, all the arithmetic we're still going to do will come out right. So for both of them, we add 1 and divide by 3. And when we do that, we end up with x is 7/3 and x is negative 5/3. So just be careful. You make sure you remember your plus or minus, and don't forget to split it up into separate answers, or separate little problems maybe when you get down to there. All right, so let's start moving towards actually completing the square, which we haven't done yet. All right, so this board is going to take us pretty close to being able to complete the square. The actual completing the square will be on the next one. But for now, we need to get started with these basic binomial square patterns. So hopefully you've seen these before. Certainly if you had me for an earlier math class, you've seen these before, but a lot of you probably didn't. So anyway, let's take a look. A plus b quantity squared. Anytime you square a binomial with a plus sign in the middle, you get a squared plus 2ab plus b squared. If you don't believe me, go ahead and multiply out that a plus b times itself. Remember, when you have a square on the outside with addition on the inside, you still have to multiply those two sets of parentheses together. Now, what I did underneath here is I replaced the a with an x. Because most of the time when we do this, we're going to be working with equations that have an x squared of some sort in them. And so I thought it'd be useful to see what this looks like a little bit better with x instead of a, because it makes it a little bit more concrete for us. So you can see I changed it to x plus b squared is equal to x squared plus 2bx plus b squared x. I'm sorry, just b squared. I did move the b in front of the x just because it looks a little bit more normal. And then down here I did the same thing for the version with the minus sign. Please notice the only difference with the minus sign is if you have a minus sign in the parentheses, you get a minus 2ab in the middle. Everything else stayed the same. But here's why this is important. When we have the x's in, it's pretty easy to see this. The last term is going to be a square. Okay, so think 25, right? 25 is 5 squared. And the middle coefficient should be 2 times whatever that number being squared is. And so we'll see a nice example of that here in a second, but that's going to really get us very, very close to being able to complete the square. Because what we're aiming to do is take a trinomial like this, or even something weirder looking, and turn it back into this binomial square. Because then we can just take a square root and solve it. And that will be the completing the square. And we're going to look at that on the next board. So let's take a look at one quick little example. This isn't really a completing the square problem because we don't actually have to change anything like we're going to have to when we do that. So I have x squared plus 6x plus 9 is equal to 15. So I'm looking at this pattern right here, right? We're hoping that it's x plus something squared. I know it's a plus sign because we have a plus sign there. And if it is, the 6 in the middle, half of that is 3, right? Because this is 2 times something. And if you square 3, you get 9, which is what we have at the end. So it looks like it works because it looks like my b is 3. And if you square it, you get the 9 at the end. And so we have this perfect pattern, and so we can factor it down to be x plus 3 squared. One really neat important thing here. If it works, and we're going to force it to work here shortly, but in this case it works already. If it works, when you divide that by 2, notice that that 3 is actually what ends up inside the parentheses with the x. And that makes it really pretty slick because you just divide by 2, and that goes in the parentheses. So anyway, we'll get to more of that here in a minute. But so we can factor this down to x plus 3 squared is equal to 15. At that point, we can take the square root of both sides. When I take the square root of the left, I just get the x plus 3. On the right, I get plus or minus the square root of 15. Now, unlike our last example, square root of 15 does not come out very nice, right? It's somewhere in between, what, 3 and 4? Yeah, so it's kind of gross. You're going to leave it as the square root of 15. Now, if you need to, you can simplify that radical, but this one doesn't. So I have two numbers over here. I'm going to subtract 3, and so I'm actually going to write my answer then as x is equal to a negative 3 because I subtracted 3 with the plus or minus the square root of 15. And this is still 2 solutions. My first solution is negative 3 plus the square root of 15. If you want to know what that is, as a decimal, you could type it into your calculator. And my other one is negative 3 minus the square root of 15. So again, we get these 2 solutions. They're pretty gross looking, but they are there. All right, so let's actually move on to completing the square, and that'll be on the next board. Okay, so here's our first problem where we're actually going to complete the square. I'm going to put directions on the next board. Unfortunately, these problems do tend to take up a little bit of space, and I have a very small board that I'm working with. So, directions on the next board. So here's my original problem. X squared plus 4x is equal to 10. Now, we don't have a trinomial on the left-hand side, so this isn't like the last problem. It's not going to factor already, although that would have been nice. We could bring that 10 over, and that would give us a trinomial, but it's not going to fit what we need. So we're going to force it into a trinomial that factors really nice. Okay, that's what it means to complete the square. We're going to force it into a trinomial that factors really, really nice. So we do that kind of the same way with what we looked at on the last board. What I'm doing, so the first thing I did is, all right, let me erase these 4s because I want to show you where they came from first. First thing I did was I put a plus and a blank on both sides. We know that to keep an equation equal, if we add something to one side, we have to add it to the other. So I am going to add a number here that will make this a perfect square trinomial. But when I add it here, I also have to add it on the other side. So how do we figure out what to add? Well, it goes back to that pattern that we looked at before. If you have the perfect form, or the perfect pattern, the number in the middle, in this case the 4, is 2 times b, right? We had that little pattern back at the beginning. Flip back and look at that. But this is 2 times b. So to figure out b, I just cut that in half. 4 divided by 2 gives me 2. Remember, we said just a minute ago that if you do this right, when you cut it in half, that number should always go on the inside of the parentheses. So look at that, we're already part of the way there. Now we just have to figure out what it is that we were actually supposed to add onto both sides. Well, when you cut it in half, the number at the end should be that number, in this case the 2, squared. Well, 2 squared gives us 4, so I'm going to add 4 to both sides. So let's do that one more time real quick, just so we can see what just happened. I took the number in the middle and cut it in half. That number ended up in the parentheses, but I also squared it to figure out what I needed to add to both sides. So now I have x plus 2 squared is equal to 14, and now we're right back where we were before. I take a square root of both sides. I don't forget my plus or minus. Square root of 14 is gross. It does not simplify at all, so we're just going to leave it there. I go ahead and subtract 2 from both sides. Remember, don't subtract inside the square root. This negative 2 is definitely not inside that square root. That's why I'm writing this as negative 2, and then plus or minus that square root of 14. And there we go. That's basically completing the square. I'll get some steps on the next board and maybe one more example. Maybe a super fun one so we can really have fun. And yeah, we'll call it good. All right, so we have the steps, and then we'll have another example. Keep running out of board space. First, get it in the form ax squared plus bx is equal to c. Any plain numbers, move them to the other side all by themselves. 2, we need to divide by a. Unfortunately, we can only complete the square when we have just plain x squared at the beginning, or y squared. I mean, it could be whatever letter, but. Step 3, divide the middle term by 2. Right? This is what we looked at in that last example. We took the middle coefficient, divided by 2, and that's what it went in parentheses with the x. Step 4, square that number and add it to both sides. Factor, which should be super easy, right? Because you're going to just stick that divided number into the parentheses, and then solve it. So this is going to be loads of fun. Let's do a really pretty sticky little example, and then we're going to be done. All right, last example. 5x squared plus 10x plus 30 is equal to 0. So the first thing I do, I don't like the 30. I'm going to move it to the other side, makes it a negative 30. Second thing, remember these are those first 2 steps we had. We can't do this with the 5 in front. Okay, it's just really not going to work out well for you. So we divide, everything has to get divided by 5. This one's nice, that at least works out okay. We just get x squared plus 2x is equal to negative 6. All right, so now we're ready to actually go into the completing the square process. Okay, we're going to divide by 2, we're going to square that, and go from there. So I take the 2 in the middle, and I divide it by 2, which gives me 1. In this case, when I square 1, I still have 1. So what that means is I'm going to add 1 to both sides, right? The number you get when you square is what gets added to both sides. And then even more conveniently, when you do that division, remember that's the number that's going to go inside those parentheses. And here's a hint, I didn't do any, but if this ends up as a negative, it just means you have a minus sign in the middle. That's not bad. So I put that 1 in the parentheses, and when I add the 1, I get negative 5. All right, so we have that. Now to get rid of that square, I'm going to take the square root of both sides. Don't forget your plus or minus. So we have x plus 1 is equal to plus or minus I square roots of 5. Uh-oh, that's lovely. It's not so bad. So we have this negative here. Remember, when we take square root of a negative, we just get an I that comes out front. All right, and we subtract the 1. Again, you can't do the subtraction on the inside, so we're just going to leave this as negative 1 plus or minus I square root of negative 5. Whew, that was fun and exciting. So I really like this stuff. Hopefully you can tell that. Hopefully you don't mind it too much. Really, it's not terrible. It's pretty straightforward, I think. You just divide by 2 and square, and you just keep doing that over and over again. We will see some other methods to solve quadratics. Please follow directions on a test, though. If I do ask for completing the square, make sure you do that. So have a great day.